let's talk about two helper functions which we can use to do operations on lists. And I will just write a list here. Let's say it's 1, 3. This is a list of numbers, and let's have this example to show how it works. And first we will discuss the function filter. The filter, as the name suggests, we can filter out some elements. And the filter function itself takes in a function which tells us whether we can take or whether we should take or should not take a certain element. And if this function returns true, then this element gets into the result. So let's see how it works. So basically you can see there is a list, a bit different, but it doesn't matter. And basically what we write is we write filter. And now the first argument is a function. And then we have this list. And the first argument, let's start with a simple function. Let's have a function f. And we have this nums here. And let's say we have to have this f function somewhere. And let's say the f function is written as we define function f, which takes in element or number. And what it does, let's make it simpler. Let's say it return whether number is divisible by 2. So basically it's an even number. What I've written here is basically it takes the remainder by dividing by 2. So basically we take a number, divide it by 2, see what's remained or what's the remainder. And if it's 0, so basically it means that this number itself is divisible by 2. So it's an even number. I could, of course, write it with an if sentence. So basically if number module 2 equals 0, then return true, else return false. But there's no point to have this conditional here. When we just want to return true or false, I can return the result of this expression. And now what happens is that it takes every element from this list. So it takes 1 and passes this value into this function. And based on the calculation, currently it's false because this is not an even number. And because it's false, then this number is not taken. With the 3, it's the same. The first one where it's actually true is this 16 here. And if it's true, then this 16 is filtered or it's taken. And also this 0 is taken. And I end up basically with a list where there are 2 values. What actually happens is that the filter doesn't return a list. So to get a list from this, I just have to add list here. So whatever it returns, I convert it into list. It's a list-like object where the elements are taken basically. But what happens is that this filter is calculated when this list is called out. And yeah, in my example, I take the numbers which can be divided by 3 or 5. So basically I would take this one, this one, this one. And no, this one not. Yes, so basically those numbers. Now, what I did here, I wrote the function separately. But as you can see, this is quite a short function, and also I had to come up with a name here. So I just picked f, but I can use a lambda or anonymous function here. So basically I could write the same. I could get the same result if I use the filter. And now instead of f, I just write the lambda function here. So lambda, let's say it's number, And now I write this part which I return here, number module q equals 0. So, and if it's true, then this element is taken, and if it's false, then it's not taken. So I have to add another. So basically it's the same. If you want, you can write a separate function here and use it here, but instead we can write the function inside this argument basically. So what happens is lambda creates a function, there is no name for this function, and the body of the function is written also in the same line. So those smaller functions are easier to write inline. So of course, if it's a lot more complex, you have to do maybe 10 lines of code, then it's hard to write it as lambda. But often those filters are quite easy. So you basically take by the number, or basically, I don't know, take elements by the length of the string or something like that. So yeah, currently only elements which are divisible by 3 or 5 are chosen. Another function is map. The map allows us to apply a function to every element. And here is an example. So let's do the same. We write map. Now we also have to write a function. Let's call this function g and nums. And also I define this function currently here. Function g, which takes in a number and returns, let's say, number plus 1. And what happens is that for every element, it takes or executes this function, and the value is replaced, or the value gets into the output list. So for example, if I add 1, I get a list 2, 4, 16, 17, 8, 1, and 102, basically. So if the input list has n elements, the output list also has n elements. But for every element, we can apply a function. So here we also want to turn it into list, otherwise we cannot see the results. So if I print out only the map, I get some map object, but the elements are not visible. So to get the elements themselves, I call out list and put the result into the list function. Or I can, of course, put this result into a variable and then apply or call out the list function with this variable as shown in the code. And in my example, I multiply every element by 2. So basically, again, I can write it with lambda list map. Now I write lambda number, and I do number plus 1 here. So whatever this variable is, it's the same. Let's say it's number or m or whatever. And I forgot there should be nums. So the list where I apply this lambda or this function. So with those two functions, filter and map, you can do a lot of nice things with lists. So you can filter out something based on the values, and then you can apply something to every value for a list. Of course, you can combine those. So first you filter out something and then you apply something. So those you can combine. And also you can combine filter with, first you filter out something and then you filter out something else from the result of the first filter. So you can do also that.